Swayam Prabha. Digital India. Educated India.
Good morning. So, in the last module we discussed the Courno model, wherein two firms were simultaneously choosing the quantity of output that they were producing. We had drawn the best response functions and figured out where they intersect to determine the Nash equilibrium, right. So, just to briefly recall, we had the inverse demand curve, which was given by P equals A minus B times Q1 plus Q2, where Q1 is the quantity of output produced by firm 1 and Q2 is the quantity of output produced by firm 2. The marginal cost of each one of these firms was constant at C, and we had first written down the profit functions and figured out what was the best response for firm 1 to each choice of Q2 chosen by firm 2, and similarly we had written down what is the best response for firm 2 for each possible choice of Q1 by firm 1. So, those best response functions were, so the best response function for firm 1 as a function of Q2 was essentially given by Q1 as a function of Q2 equals A minus C minus B Q2 by 2B, and the best response function of firm 2 for each choice of Q1 chosen by firm 1 was Q2 as a function of Q1, which is equal to A minus C minus B Q1 by 2B. We had then drawn these best response functions. So, when we graph them, so we have Q1 on the x axis, Q2 on the y axis. So, when Q2 is equal to 0, firm 1 essentially is a monopolist and produces the monopoly output A minus C by 2B, and when firm 2 produces A minus C by B, which is the competitive level of output, firm 1's best response is to not produce at all. So, if I connect these two lines, I get the best response function of firm 1. So, this is the best response function of firm 1 for each choice of firm 2's output. Similarly, if we were to draw the best response function for firm 2, when Q1 is equal to 0, firm 2 essentially is a monopolist, so and produces the monopoly output A minus C by 2B, and when firm 1 produces the competitive level of output, which is A minus C by B, then firm 2 decides not to produce at all, and the best response function for firm 2 is as follows. So, this is the best response function for firm 2, and we said that the Nash equilibrium output Q1 star Q2 star is a pair of mutually best responses, which means Q1 star is a best response to firm 2's choice of Q2 star, and Q2 star is a best response for firm 1's choice of Q1 star. We solved for the Nash equilibrium outputs, and they were Q1 star equal to Q2 star equals A minus C divided by 3B. So, we got this as the Nash equilibrium output, and so the total industry output. So, the industry output is Q1 star plus Q2 star, which is 2 times A minus C divided by 3B. Therefore, the industry price or the equilibrium price in this market, which is A minus B times Q1 star plus Q2 star. So, if I substitute the total industry output 2 times A minus C by 3B, we would get the industry the equilibrium price P star as A plus 2C divided by 3, which then implies that the profit of firm 1, which is P1 star minus C times Q1 star, right, where Q1 star is its Cournot output, is given by A plus 2C upon 3 minus C. So, that is essentially A minus C by 3 times A minus C by 3B. So, that gives us A minus C whole square by 9B, and by symmetry firm 2's profit also turns out to be A minus C whole square by 9B. Now, so the total industry profit is 2 times A minus C whole square by 9B. And before we ask whether industry profits are maximized or not, let us look at how consumers perform in this Cournot market compared to the competitive market and the monopoly market, and how the producers perform. So, the total Cournot the competitive level of output is A minus C by B is greater than the total industry output under Cournot, which is we just computed as 2 times A minus C by 3B, and that is greater than the monopoly output, which is A minus C by 2B. Right. So, that is obtained by doing a simple comparison of the total quantities that are produced in each one of these markets. Now, because the competitive market produces the maximum total output, the competitive price, which is equal to marginal cost, is less than the price under Cournot, which we just computed as A plus 2C by 3, A plus 2C by 3 is less than the monopoly price. The monopoly price is A plus C by 2, monopoly price is A plus C by 2, right. So, now if I look at how the consumers are doing, the consumers in the competitive market buy a lot of products, are able to get access to A minus C upon B quantity of output, and they buy it at a very low price. So, the consumer surplus under perfect competition is greater than the consumer surplus under Cournot, is greater than the consumer surplus under a monopoly market, right. And how do the producers react? So, for the producers, the monopoly output gives the maximum profit compared to the Cournot profit compared to the perfectly competitive level of output. So, the producers prefer, so the profit under perfect competition for the producer is less than the profit under the Courno model, is less than the profit under monopoly. Okay. So, this is so why were we interested in this? Because we are interested in knowing under the Courno model how do the outcomes, or rather what can we say about certain welfare aspects when we look at the consumer surplus, when we look at the profits of the producers, when we look at the total output, and when we look at the price compared to the competitive model and the monopoly model. So, now before we leave this, let us ask whether industry profits are maximized in the Cournot model, right. So, are industry profits maximized? So, let us ask the question, are industry profits maximized? Let us think about this. Now, where is the industry profit maximized? Well, the monopolist exercises market power and compares his marginal revenue with the marginal cost, chooses to produce an output which is A minus C by 2B and charges a price which is A plus C by 2. So, we know that industry profits, so are industry profits maximized in the Cournot model? No, the industry profits are maximized at the monopoly level of output. At the monopoly level of output. So, if I look at this graph, now what are the monopoly levels of output? Well, A minus C by 2B, if firm 2 were to produce A minus C by 2B, that would be a monopoly level of output. If firm 1 were to produce A minus C by 2B, that would be a monopoly level of output, and any combination of Q1 plus Q2, any combination of Q1 plus Q2 which adds up to A minus C by 2B, right, where Q1 plus Q2 equal to A minus C by 2B would be the total monopoly output of where the industry profit is maximized. So, with that in mind, right, let us ask, suppose the two firms decided to produce Qm divided by 2. So, essentially they decided to produce A minus C by 4B each, right. So, the monopoly output is A minus C by 2B, right, and each of these firms want to produce half of it. In particular, suppose firm 2 is producing A minus C by 4B. So, in other words, if I go to the previous graph, so A minus C by 4B is somewhere here. So, let us say firm 2 is producing A minus C by 4B, right, and firm 1 which had earlier agreed to produce A minus C by 4B, let us ask whether firm 1 is going to honor its word or not. Well, notice that the moment firm 2 produces A minus C by 4B, firm 1 is going to ask what is its best response to firm 2's choice of A minus C by 4B. Now, we already know that the best response function for firm 1 takes this particular form, right. So, it is A minus C minus B times Q2 by 2B. So, for each choice of Q2, firm 1 is going to choose its best response Q1, which is based on its best response on this best response line. So, when firm 2 produces A minus C by 4B, firm 1 is going to deviate and is going to choose a quantity which is going to be obtained from its best response line. Let us figure out what that is. So, firm 1's best response. So, firm 1's deviation level of output is going to be 1 upon 2B A minus C minus B times Q2, but Q2 is essentially A minus C by 4B. So, essentially we have the B getting cancelled. So, this is equal to 3 times A minus C by 8B. So, when we said that the two firms are producing half of the monopoly output, even if firm 2 were to honor its word, firm 1 has a strictly profitable deviation and chooses an output from its best response function, and that output turns out to be 3 times A minus C by 8B. Now, let us ask, with this output what is the total quantity produced? So, you have Q1 deviation plus firm 2's output, which is half of the monopoly output, adding up to 3 times A minus C by 8B plus A minus C by 4B. This adds up to, so let us ask what this would be. So, this would be, so if I have an 8B here, so that will be 3 times A minus C plus 2 times A minus C. So, that will be 5 times A minus C by 8B. So, this would be the total output, which means that the deviation price which is given by the inverse demand curve A minus B times Q1 plus Q2, which is 5 times A minus C by 8B, that turns out to be 3A plus 5C divided by 8, which then implies that firm 1's deviation profit is the deviation price, which is 3A plus 5C divided by 8 minus the marginal cost times the deviation output that it wants to produce, which is 3 times A minus C by 8B. Now, if I do this algebra, so I will have a 3 times A minus C times a 3 times A minus C. So, that is 9 times A minus C whole square by 64B. And notice this is strictly bigger than the Cournot output of A minus C whole square by 9B. 9 upon 64 is greater than 1 upon 9. So, this is the Cournot output, right. So, firm 1 has a strictly profitable deviation, and will therefore not produce half of the monopoly output, right. So, even if the two firms agreed and let us say wrote down on a piece of paper saying that I promise to produce half of the monopoly output and you also will produce half of the monopoly output. So, even if firm 2 were to honor it, right, firm 1 will strictly deviate and produce a deviation output. This is what we computed as the deviation quantity, which is 3 times A minus C by 8B. So, this is 3 times A minus C by 8B, right. So, the best response functions essentially determine what is the output of each firm for each possible choice of the quantity chosen by the other firm. So, the equilibrium in the Courno model is that the two firms produce A minus C by 3B, the price that is obtained is A plus 2C by 3, and each firm makes a profit of A minus C whole square by 9B. Okay. Now, let us move on. So, now let us think of a different model, so which is the Berthra model of oligopoly. In the previous model, which is the Courno model, the two firms were simultaneously choosing the quantity and the price was determined from the inverse demand curve. In the Berthra model, the two firms are going to be simultaneously choosing the price and the two firms are simultaneously going to choose the price and they produce enough output to meet the market demand. So, the two firms simultaneously choose prices and produce enough output to meet the market demand. Right. So, for the moment we will also assume that the firms have no capacity constraints, which means whatever is the quantity that is demanded by the consumers, either of the firms can meet that entire market demand. Firms do not have any capacity constraint. We will relax this assumption later on and we will see how the predictions of the Berthra model changes when we remove this assumption of firms not having any capacity constraint. Okay. Now, if firms choose different prices, then the consumer is going to purchase from the firm which charges the lowest price, right. So, if there are let us say two firms, firm 1 is charging P1, firm 2 is charging P2 and P1 is less than P2, then all consumers are going to buy the good from firm 1. So, if firms choose different prices, consumers will buy the good from the firm which charges the lowest price. Now, if multiple firms charge the same lowest price, then the market is essentially split between these firms. So, if more than one firm sets the lowest price, then all firms doing so split the market, share the market demand. Right. So, now, let us formally set up the model. So, the players are the two firms, firm 1 and firm 2. So, these are the two firms, these are the two players, right. The strategies for the two players are choosing a price, right, choosing a set of price, right. So, firm 1 is going to choose a price which is P1, firm 2 is going to choose a price which is P2. So, we will talk about the payoffs in just a moment. Let us first write down what the demand curve is. So, now the demand curve is given by Q equals A minus P, where P is the minimum of the price charged by the two firms, right. So, recall that if firms choose different prices, consumers will buy the good from the firm which charges the lowest price. So, if I have firm 1 charging P1 and firm 2 charging P2, the actual price that the consumer will pay to buy the product will be the minimum of P1 and P2. As before, let us also assume that the marginal cost, let us assume that the marginal cost is constant at C for both the firms. Now, so with this in mind, let us write down the payoffs. So, what are the payoffs to the two firms? So, let us think about the payoff to firm 1. So, firm 1's profit is total revenue minus total cost. So, that is essentially the price that it charges P1 minus the marginal cost C times the quantity that it sells. Well, recall that the demand curve QP is A minus P, where P is the minimum of P1 and P2. So, if P1 is less than P2, then essentially the entire market demand is captured by firm 1. So, the quantity is going to be A minus P1, right. So, where P1 is less than P2, right. If both firms charge the same price, which is when P1 is equal to P2, they split the market. So, firm 1's profit is P1 minus C times A minus P1 divided by 2. So, P1 is equal to P2, and when P1 is greater than P2, which is firm 1 charges a price which is larger than the price charged by firm 2, then as per our model all consumers go to firm 2. So, firm 1 essentially sells 0 units. So, that is essentially going to be 0 if P1 is greater than P2. And for completeness, let us also write down the profit of firm 2. Firm 2's profit again is total revenue minus total cost. So, that is going to be P2, the price that it charges, minus the marginal cost times the quantity that it sells. Well, the quantity that it sells will be A minus P2 provided P2 now is less than P1. So, if the price charged by firm 2 is lower than the price charged by firm 1, then it essentially gets the entire market demand. Now, if both the firms charge the same price, then essentially they split the market. So, firm 2's profit is A minus P2 divided by 2 when P2 is equal to P1, and when firm 2 charges a price which is greater than the price charged by firm 1, essentially it does not sell anything because no consumer comes to firm 2, they all go to firm 1 and P2 is greater than P1. Now, what are we interested in? We are interested in finding, so we want to find the set of prices, that constitutes a Nash equilibrium. So, we want to compute a set of prices which constitutes a Nash equilibrium. Now, notice Nash equilibrium is a pair of mutually best responses. So, to get this, to get the Nash equilibrium, we need the best responses, right. So, unlike the Courno model where we had profit functions which were continuous everywhere, we could simply take the derivative of the profit functions and we could draw these best response functions. Here, because of the discontinuity, right, because when P1 is less than P2, the profit takes a particular form. When P1 is greater than P2, it becomes 0. It is not very convenient to take derivatives and draw the best response functions. So, we will start with first principles and we will look at what is the best response for firm 1 for each possible choice of P2 chosen by firm 2, and then we will do the same thing for firm 2 also. So, if I wanted to write down the best response function for firm 1, so let us think about it this way. So, suppose P2 is less than C, recall C is the marginal cost, right. So, and firm 2 charges a price which is less than the marginal cost. What is the best response function for firm 1? So, we will say this is the best response function for firm 1 as a function of P2. Now, if P2 is charging a price which is less than C, which means firm 2's profit is already negative, what can firm 1 do to maximize its profit? Well, if firm 1 chooses a price which is equal to what firm 2 sets, right. So, let us say P2 is some number which is less than C and firm 1 also sets that same price, then essentially they split the market, but then firm 1's price also is lower than the marginal cost now because P1 is equal to P2. So, its profit becomes negative. So, when P2 is less than C, the best response for firm 1 is a set of price P1 such that P1 is strictly larger than P2. So, when firm 2 chooses a price which is less than C, firm 1 does not want to sell anything. The best profit that it can get is a profit of 0, which it obtains by choosing a price which is strictly larger than the price chosen by firm 2. When P2 is exactly equal to C, what is the best response for firm 1? Well, the best response for firm 1 is the set of price P1. Now, if I set a price P1 which is also equal to C, then we both split the market and my profit is going to be 0. If I charge a price which is larger than C, no consumer is going to come to me, so I do not sell anything, again my profit is going to be 0. But if I choose a price P1 which is less than C, then I get the entire market, but now I am pricing below marginal cost. So, my profits are negative. So, the best response for firm 1 is to choose any price which is greater than equal to C. When firm 2 chooses a price which is between C and let us say the monopoly price. Notice here prices are real numbers, right. So, what is firm 1's best response? What is firm 1's best response? Well, firm 1, so let me just think about this here. So, let us say we have C and let us say this is some PM, right. So, this is the monopoly price, and let us say firm 2, is somewhere here and is choosing a price P2. Now, what can firm 1 do? Well, because firm 2's price is greater than C, firm 1 can essentially choose a price P2 minus epsilon, where epsilon is a number which is tending to 0, right. So, if I undercut firm 2 by a tiny bit, then essentially I am pricing below what firm 2 is charging. So, I am going to get the entire market demand and my profits are going to be positive. The problem for us though is that because epsilon, because prices are real numbers here, if I choose an epsilon, I can come up with some other epsilon which is even more closer to P2, which will still be sufficient to undercut firm 2, capture the entire market demand and increase my profits even more, right. So, if I choose epsilon, I can come to epsilon by 2, then thereafter I can choose epsilon by 4 and get even more closer to P2. The issue is that by undercutting I will be able to capture the entire market demand, but there is no optimal undercutting price that which I can choose. So, in other words, I would want to be as close as possible to what firm 2 is charging, just undercut it by the tiniest possible amount, but there is no best response that I will have, which means that when firm 2 is pricing at a level between the marginal cost and the monopoly price, there is no best response for firm 1, right. So, this would not be the case if the denomination in which we were measuring, let us say, prices were in the smallest denomination in which I could measure it is, let us say, in let us say 50 paisa, then if firm 2 were charging a price P2 here, all firm 1 had to do was choose a best response which is P2 minus 0.5. But now, since for our case prices are real numbers, this does not exist. So, there is no best response for firm 1. Finally, when firm 2 is choosing a price which is strictly greater than the monopoly price, firm 1's best response is simply choosing the monopoly price, right. So, when firm 2 is choosing a price strictly larger than the monopoly price, firm 1's best response is to simply choose the monopoly price. Okay. Now, so we are going to graph this on the side. So, we are going to draw the best response functions. So, this is P1 and this is P2, and let us say this is the 45-degree line. So, I have C here, I have PM, I have C and I have P, right. Before we do that, let us also write down the best response function for firm 2. So, we would do a process which is similar to what we did for firm 1. We will ask for different possible choices of firm 1's price, for different possible choices of P1, what is the best response for firm 2. So, which means if P1 was less than C, right, the best response for firm 2 to firm 1's choice of that P1 is to choose a price which is strictly larger than firm 1's price, because this way I am guaranteed that I will not sell anything and my profits are going to be 0. If I choose a price which is exactly equal to what firm 1 charges, then we split the market, I get half the market share. The problem is the price is now below marginal cost, but my profits therefore are 0. So, the best response for firm 2 is a P2 such that P2 is strictly larger than P1. So, I want to ensure that I do not sell anything. If P1 is exactly equal to the marginal cost, then the best response for firm 2 for firm 1's choice is to choose a price P2 which is either C, in which case we split the market, but because my price also is equal to C, profits are 0, or choose a price P2 which is strictly larger than P1, because if I now price at a level which is greater than what firm 1 is setting, then again nobody is going to come to me and my profits are going to be 0. So, P2 greater than equal to C. Similarly, if firm 1 is choosing a price between the marginal cost and up to the monopoly price, right. So, take the extreme where firm 1 is exactly choosing the monopoly price. So, if I am firm 2, I would want to undercut firm 1 by the tiniest possible amount. So, I would price at P1 minus epsilon, but as we had the discussion a little while earlier, there is no such optimal epsilon. So, the moment I undercut firm 1 by a tiny amount, I can always find another epsilon which puts me closer to firm 1's price, which will further increase my profit. So, the best response for firm 2 to firm 1's choice of P1 essentially is null. And finally, if P1 chooses a price greater than Pm, firm 2's best response is essentially charging the monopoly price, right. So, there is a lot of symmetry here. So, we have the entire characterization of best response functions for firm 1 and for firm 2. Now, what is left? So, to figure out the best response to figure out the Nash equilibrium, we need to ask where do the best response functions intersect, right. So, now the best response functions are actually set valued, they are a lot more involved, right. So, let us start with firm 1's best response, P2 less than C. So, I have firm 1's choice. So, for let us say P2 is somewhere here, P2 is less than C. So, if firm 1 chooses a price here, or rather firm 2 chooses a price here, then firm 1 wants to choose a price which is strictly greater than firm 2's price. So, I want a price which is strictly greater than firm 2's price. So, any of these prices are valid prices. Similarly, if firm 2 were to choose a P2 which is here, then firm 1 wants to choose a price which is strictly larger than firm 2's price. So, those are prices which are somewhere here all the way until C, wherein, so if I were to draw this entire thing, so I would get this entire set of prices which denotes the best response of firm 1, right. So, notice it does not include the 45-degree line, but any price P1 which is strictly larger than P2 is a best response for firm 1. Now, when P2 is equal to C, when P2 is exactly equal to C, right. So, let me just draw this again. When P2 is exactly equal to C, what is firm 1's best response? Firm 1's best response also is to choose a price which is exactly equal to C or something greater. So, now this includes the point C and anything greater than C, right. So, this is firm 1's best response. Now, for any price P2 which is between C and Pm. So, let us say Pm is somewhere here. Okay, so, for any price between C and Pm, firm 1 does not have a best response. So, it is a null set, and for any price P2 which is greater than Pm, for any price P2 which is greater than Pm, firm 1's best response always is to choose a price Pm. So, this is what we have. So, this is the best response function for firm 1. Okay. Now, let us do it for firm 2. Now, if I look at firm 2, for any price P1 less than C. So, let us say firm 1 chooses a price which is here, firm 2 wants to choose a price which is greater than the price chosen by firm 1. So, I have any price which is greater than this price would do, right. So, it does not include the 45-degree line, but any of those prices are fine. So, if firm 1 chooses a price which is here, firm 2's best response is to choose a price which is here, right. So, this is the best response for firm 1 for any of those prices chosen by firm best response for firm 2 for any of those prices chosen by firm 1. Now, when P1 is exactly equal to C, right. So, P1 is exactly equal to C, what do I have? The best response for firm 2 is to also choose a price which is C and any price which is greater than C. For all prices P1 between C and Pm, there is no best response, right. So, it is a null set, and for any price P1 which is greater than the monopoly price, firm 2's best response is to always choose the monopoly price. So, we have firm 2's best response here. Right. So, now notice the Nash equilibrium is where the two best response functions intersect. Now, where do the two best response functions intersect, right. So, the purple and the blue one, there is an intersection point where both of them overlap. So, P1 star P2 star equal to C comma C is the Nash equilibrium. Right. So, the surprising result is that when you have these two firms which are simultaneously choosing the prices, their marginal cost is C, then the Berthra Nash equilibrium price essentially is each firm charging a price which is equal to the marginal cost. Right. So, the surprising part of this discussion is that with just two firms, with only two firms, we get the competitive solution. Right. With only two firms we get the competitive solution, because recall in a perfectly competitive market the outcome, the price that is obtained in the market system is a price which is exactly equal to the marginal cost. Here also we have a setup where there are just two firms in the market. So, we would expect that these two firms would have some amount of market power, right, because so this is a duopoly which is somewhere in between a monopoly and perfect competition. So, two firms closer to one firm, but far away from many firms. So, we would have expected that the outcome would be somewhere sort of closer to the monopoly outcome, but it turns out quite surprisingly that we get the competitive solution. This is called the Berthra paradox. This is called the Berthra paradox, right. Now, before we leave this model, assumption in this whole setup is that firms do not have any capacity constraints, and as with the Courno model, the firms are also producing identical products, right. So, as far as the goods, as far as the consumers are concerned, these goods are perfect substitutes, right. So, we will see what happens when we relax some of those assumptions in a few moments, right. But for the moment we have these two classic oligopoly models, the Courno model where firms are simultaneously choosing quantity which gives an outcome of output and prices, and the Berthra model where firms are simultaneously choosing prices which gives the surprising outcome that price is exactly equal to marginal cost. What we want to do next is we want to ask how can we come out of the Berthra paradox. How can we come out of the Berthra paradox? There are a couple of models that we will talk about. So, and the first model that we will talk about is we will relax the assumption that the firms produce homogeneous goods and instead consider a model where the firms are producing differentiated products. So, this is the first time where we would introduce this notion of product differentiation in the context of an oligopoly model, right. And the reason why we want to bring this particular feature of product differentiation is that in many markets there are products which compete with each other and they are not perfect substitutes. So, in many markets products that compete with each other are not perfect substitutes. So, there are many such examples when we look at the real world. So, for example, in the automobile segment, right. So, if I look at economy sized cars, there are multiple cars, right. So, let us say a WagonR or an i20 or a Honda vehicle. So, all of them have certain attributes which are not identical to what the other vehicle has. If I look at laptops, I have HP, Lenovo, Sony, which have sort of which have similar specifications, but are not identical products, right. So, which is why in many markets products that compete with each other are not perfect substitutes. in the previous two models the goods were perfect substitutes, right. So, as far as the consumer was concerned, it really did not matter whether I buy the good from firm 1 or from firm 2. Okay. So, some consumers will prefer the product of firm 1, some consumers will prefer the product of firm 1 over the product of firm 2, right, even if the price of firm 1's product is greater than the price of firm 2's product. So, the price of firm 1's product is greater than the price of firm 2's product, right. We would however expect that as firm 1 raises its price, the quantity demanded would fall and consumers would move and substitute towards firm 2's product, right. So, even if firm 1's price is greater than firm 2's price, there might be some consumers who would still prefer firm 1's product over firm 2's product, but as firm 1's price keeps on increasing, gradually some consumers will shift from firm 1 to consuming firm 2's product. Okay. So, the question that we want to ask is, what are the implications of introducing product differentiation in the Berthra model. This is the question that we want to ask. Okay. So, to do this we will set up an analytical framework and see whether by introducing product differentiation we are able to move out of the Berthra paradox. Okay. So, let us say that there are two firms, firm 1 and firm 2, that are producing goods which are imperfect substitutes, right. So, the demand for firm 1's product, which is Q1, will depend not only on its own price, but will also depend on firm 2's price. The demand for firm 2's product will depend not just on its price, but it will also depend on the price of firm 1's product, which is P1. Okay. So, these are the demand functions. Okay. Now, let us look at firm 1's. So, if I have, so let us look at firm 1's Q1 and if I have P1. Now, with respect to its own price, I have the standard downward sloping demand curve, right. So, I am going to call this as Q1 and let us say the price of firm 2's product is P2A, right. So, if firm 2 were to price its product at a level P2A, I can get firm 1's demand curve. Now, suppose firm 2 increases the price of its product to P2B, right. So, P2A is greater than, or rather P2B is greater than P2A. Now, if the price of firm 2's product is greater than is now increased, right, and the goods are substitutes, then I would have consumers who are moving towards consuming firm 1's product. So, I would expect the demand for firm 1's product to increase, and let us say the new demand for firm 1's product is Q1 P2B, right. So, which means that at some price P let us say P hat, the original quantity demanded was let us say Q1 hat A. Now, the quantity demanded is Q1 hat B, where Q1 hat B is greater than Q1 hat A, right. So, in other words, as P1 increases, at P1 the quantity demanded of good 1 increases from Q1 hat A to Q1 hat B. As before, let us assume that the two firms have identical marginal cost. So, the marginal cost is C for both the firms. marginal cost is C for both the firms. The question that we want to ask is, what are the Nash equilibrium prices? Now, to get the Nash equilibrium prices, as before, we will write down the best response functions, right. So, we will write down the profit function of firm 1, figure out what is the best response for firm 1 to each choice of firm 2's price. We will do the same thing for firm 2, and then we will figure out what are the P1 star and the P2 star. Okay. So, let us first write down the profit function of firm 1. So, firm 1's profit is the total revenue minus the total cost. So, the total revenue essentially is P1 times Q1, which depends on P1 and P2, minus the total cost. Well, the total cost is C times Q1 of P1 P2, right. So, what is firm 1 doing? Firm 1 is choosing its price P1 to maximize the profit. So, by taking a particular price P2 as given. So, firm 1 believes that firm 2 is choosing a price P2. For that price P2, what is my best response? So, d pi 1 dP1 is essentially, so if I take the derivative here, so that is going to be Q1, it is going to be Q1, I am just going to suppress Q1 as a function of P1 and P2, we will put it later just to save space, plus P1 times dQ1 dP1 minus C times dQ1 dP1, which is the same as Q1 plus P1 minus C times dQ1 dP1. What this essentially means is, so there are these two terms. The first term here is essentially capturing what is the increase in profit due to an increase in price which is coming from the inframarginal units, right, and there are Q1 of those in total, right. So, increase in profit from the inframarginal units, which are Q1 in total, right. The second term, which is actually negative because dQ1 dP1 is negative because the demand curve is downward sloping. This term essentially tells us what is the reduction in profit from the lost sales, right. So, when P1 increases, the quantity demanded of good 1 falls, and for each one of those units the margin was P1 minus C, but because those units are not sold, then I have lost an equivalent amount of P1 minus C times dQ1 dP1. So, this is the reduction in profit due to lost sales, due to the margin from the lost sales, right. These are the two terms, and the necessary first order condition is that firm 1 takes the derivative of the first order of the profit function with respect to P1 and sets that to equal 0. Similarly, firm 2's profit pi 2 is going to be P2 times Q2, which depends on the price of good 1 as well as its own price, minus C times Q2 of P1 P2. Now, dP2 dQ2, right, following a similar analogy. So, I am going to have a Q2 plus a P2 times dQ2 dP2 and minus C times dQ2 dP2. We will pull these two things together. So, this is Q2 plus P2 minus C dQ2 dP2, which is equal to 0, right. So, I have the two first order conditions for the two firms, and we need to find out where the two first order conditions when we will simultaneously solve the two first order conditions to figure out what the optimal prices are. Okay. So, now the Nash equilibrium of the Berthra game, right, the Nash equilibrium of the Berthra game, right, is a pair of prices P1B and P2B, right, is a pair of prices P1B and P2B such that they solve these two first order conditions, right. So I call this as 1 and I call this as 2, such that they solve the two first order conditions, such that if I rewrite the two first order conditions, I will have Q1 of P1B P2B. Notice that when I had written down this first order condition, I had actually suppressed the prices here. So, essentially now we will write those explicitly, because the Nash equilibrium prices are P1B and P2B, right, plus P1B minus C dQ1 dP1. So, P1B minus C dQ1 dP1, which is equal to 0. And similarly from equation 2, I am going to have Q2 as a function of P1B P2B plus P2B minus C dQ2 dP2 equal to 0, right. So, Q2 of P1B P2B plus P2B minus C dQ2 dP2 P1B P2B, which is equal to 0, right. So, my Nash equilibrium prices P1B P2B simultaneously solve these two first order conditions 1 and 2. Now, let us look at this let us look at these two conditions. Now, obviously this term here is positive because it is the quantity, right. Now, notice, so I have the first term which is positive, the second term, this expression is actually negative, right, because this is coming from my inverse demand curve, or because the demand curve is downward sloping rather. So, as price increases Q1 falls. So, it must necessarily mean that this expression be positive. So, essentially it implies that P1B must be necessarily greater than C. Similarly, from the second condition, I have the Q2 which is positive, dQ2 dP2 is negative. So, it must then mean that this expression be positive for the equality to hold. So, I have P1B greater than 0 and P2B greater than C. Now, notice this is different than the Berthra equilibrium that we solved in our baseline model, where the Berthra Nash equilibrium was P1B P2B exactly equal to the marginal cost, right. So, when products are different, so essentially when products are differentiated, right, when products are differentiated, firms realize that they cannot undercut their rival and capture the entire market, right. So, when products are differentiated, firms soften price competition and charge and we would rather say and the sort of the incentive to undercut is a lot lower, right, because the price competition is a lot softened, right, and incentive to undercut, which was very strong in our previous Berthra in the baseline Berthra model, to undercut the rival is lower, right. As a result, the intensity of price competition is reduced. Intensity of price competition is reduced, and both firms exercise market power in equilibrium. Right. So, this is our first analytical framework, wherein we said can we construct a model where we have an outcome wherein we are moving out of the Berthra paradox. So, here is an outcome where by introducing product differentiation we are able to move out of the Berthra paradox. Okay. Now, just to push this a little bit further, now instead of the two firms we had a monopolist who was choosing the same price, choosing the two prices P1 and P2, right. So, what would the setup look like? So, the monopolist is choosing not just P1 and P2, so to maximize the joint profits. So, the profit of the monopolist would now, so instead of writing down the first the two profit functions, one for firm 1 and one for firm 2 separately, what we would do is we would write down the monopolist's profit function as P1 times Q1 of P1 P2 plus the revenue from the sale of product 2, which is P1 P2, minus C of Q1 P1 P2 minus C of Q2 P1 P2, right. So, essentially now there are going to be 3 effects. So, a change in Pi, right. So, I could be 1 or 2. So, a change in the price of one of the product, the ith product, has 3 effects. One, it increases the profit, from the inframarginal sales, right, as before. So, we had the first condition, which is the increase in P1 leads to an increase in profit. So, these were the inframarginal sales, right. The second condition is an increase in P1 leads to a reduction in the quantity of its own product. So, I lose the margin from the lost sales, right. So, decreases profit from foregone margin on lost sales. And the third part is that now an increase in Pi will boost the demand for good J and thereby increase profit, increases profit as demand for J increases, right. So, if I take the first order condition generally with respect to say Pi, where I could be 1 or 2, well I would have, so let us say I is 1. So, I would have a Qi of Pi Pj, right, and if I were to simplify the expression, I would get a Pi minus C dQi dPi, right. So, if I split it and combine the expressions, 1 dQi dPi coming from here and then a minus C dQi dPi coming from there, plus I would have a Pj minus C dQj dPi, right, which is again, so there is a I am suppressing these quantities which must be equal to 0. So, now notice there are 3 terms compared to the 2 terms that I had earlier. So, now we have these 3 terms. So, this is the inframarginal units, these are the foregone margin from the lost sales, and this is the increase in profit due to the demand for firm 2 increasing. And in particular, while this expression is negative, this expression is so in particular, if I were to look at, so this expression obviously is positive. So, this expression is negative, so which makes the whole expression negative, and since dQj dPi is positive, this entire expression is positive, right. So, the effect of that is, so I have one negative term and I have these 2 positive terms, and I can write down the 2 first order conditions, one with respect to P1, one with respect to P2, right. So, there will be a solution P1m, P2m, which will satisfy the two first order conditions. So, I do it with respect to firm with respect to P1 and I do it with respect to P2, and because of these 3 terms, of which 2 are positive, 1 is negative, we would expect that the P1m that we solve for is greater than the P1b that we solved earlier, and the P2m that we will now get will be greater than the P2b that we solved earlier. Thank you.